Hi. I didn't even start yet. Okay. Welcome to my little talk here. It's about web apps and hackers and you. And first, I'd like to introduce myself a little bit to you. So, joernchen or Jörn, my handle is an extended version of my actual passport name. By day, I'm doing security consulting at Security Labs, so working for our dear keynote speaker, or in his company at least. At night, I either hack other stuff, which I'm not getting to hack at work, but more like fun privately, or I go out and get wasted or spin a bit. My fetish kind of thing is Ruby on Rails applications, so many examples today will be based on Ruby on Rails, but I hope you can generalize from those to other platforms, languages, and frameworks. And the most fun CVE I ever had was a format string issue in sudo back in 2012. I'm still getting emails for that bug where people get this actual bug as an assignment to exploit it, so that was fun. I'm on Twitter, and the stuff down there is just my GPG key. So if you want to contact me securely, use that key. Okay, but let's start with the content. What's this all about? So I've been asked to give a presentation here, so I had to come up with something. I wanted to not only show some patterns of vulnerabilities in web applications, but more also kind of solutions where what you should keep in mind if you're developing an application or if you're deploying or running infrastructure. So mainly this is about developers, 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 developers. Also, it's about code. So here in the audience, I guess, are some, whom of you, please raise your hand if you're actively developing some kind of application, be it a web application or non-web application. Okay, not too many. Oh, no, all right, that's all right. Developers write code, and that's not the only thing they do. They get bug reports, they have to fix their code, they have to maintain their code, and have to live with it. Once you started it, I guess it's hard to get rid of it, so you got to maintain it to a certain extent. And I'll try to show you some things you should keep in mind while maintaining your code from a security perspective. So the non-goal of this talk is making fun of anyone, not even developers. Actually, I want to point out some mistakes and pitfalls you can trip in, and some approaches to get rid of a good amount of security issues just by the way you're dealing with your code base and dealing with bug reports or security reports. Okay, we almost had this. The developers I've seen now, who of you is kind of a project manager, product manager, like herding developers? No one? One? Okay, at least one, that's good. And who's a hacker? Come on. No hackers here? This activity, come on. Okay, a couple, that's fine. Cool. Cool, so, hackers. Oh my God. So this is hackers, like guys with ski masks and a hammer smashing your computers. Actually, there are certain types of hackers. The ones with the ski mask, the black hats, which are the real bad guys. The ones with the white hats, that are the good guys, which save the internet on a daily basis. And there's something in between. If you have a ski mask and a white hat at the same time, and you may or may not do something shady, then you're called a gray hat hacker. So, white hat, non-malicious, black hat, pure evil are aiming all the boxes, and gray hat, yeah, malicious at will, at somewhere in between. May or may not be friendly, just for the terminology. But then, the problem is, security is hard, and I mean it not in a way that this exploit does not work because ASLR is in place, or you cannot pop a shell because there are some regex you cannot bypass. Security is hard enough for the hackers, but it's even harder for the guys who write the code to defend, because that's a way harder problem to defend your whole code base, because one hacker needs one bug which he can successfully exploit. And you need to close all the bugs, because only then you're safe enough, and still things might go wrong. So an important security feature are passwords. Who of you does not have a password? Good. So who of you has used a password reset in the last half year? Password reset is a pain in the... It's painful. So usually it works like this. This is a Rails-specific example. You fill out the form which says enter your email, and you get a link to reset your password. This link would contain some kind of secret, and then you redeem that secret for a prompt where you can input a new password, or even are being logged in directly. In Ruby, it typically looks like this. We have our super random, secure random token, and we'll find the user by its reset token. That's a very simplified thing. So this is how it's usually done. And there is a problem, at least with MySQL. I have to switch to MySQL now because that's important for the password reset process we just saw. If you compare a number to a string starting with the same number, MySQL will return that's true. Or if you have a string with a non-numeric start and compare it to 0, MySQL will return as well, and this evaluates to true in MySQL. That's almost like PHP type juggling, and we can benefit from a attacker's perspective from this in context of Ruby on Rails applications, because with XML in the older versions and still with JSON input, we can actually give in the parameters a numeric, not a string of like the string 1, but the number 1, like the fixnum in Ruby terminology. So to demonstrate this, here we got a legit password reset. So we redeem the full token. It's a very long, very secure token. You could never guess it. And you set your new legit password. And then a hacker comes along and uses the number 0, which would match this token, and sets its own password. So this is pretty broken. And a lot of Rails applications made this mistake. For instance, the Black Hat CFP system. So I was able, without even submitting anything there, becoming a review board member, just by resetting random accounts. And one of those was a review board member, so I could look at all the talks and maybe download them or upload them. But instead, I was a whitehead and told them, and yeah, was invited to Vegas. Device is an authentication plugin which is very popular for Ruby on Rails applications. They had the same problem, and this is pretty widespread. So there was a real issue because you could actually reset random accounts, and if no password reset is pending on any user, you would just go and type admin admin would get a password reset link, would think I didn't do this, someone pranked me, but you could, with sending a number instead of a string, reset its password. Well, pretty bad. But the main point here is not only that we can reset passwords, but whom would you blame for this? Whose fault is this? Like, it could be, oh my God, MySQL is stupid, really stupid. It compares strings to numbers and it does weird things instead of just throwing an arrow at you. You could say Ruby on Rails framework is stupid for letting me pass numerics instead of strings, or not telling me that this would have side effects, or the developer is stupid because he didn't know, or I am stupid because I disclosed this technique because I'm a bad hacker. So I think you cannot really blame anyone, but it's a big complex thing, a Ruby on Rails application. I mean, you got a web server, a database, the framework, the programming language, the developer who uses all these tools to create something, and you have to be aware of a lot of side effects and cannot really judge if it's good or bad, because there might be stuff which isn't even documented, which even the framework developers didn't know. So I would really not blame anyone, but it's a problem. So password reset, part 2. Own cloud, so this time PHP. They work like this. So we compute a SHA-1 of the username and unique ID. First of all, this is not a good random source. So you might be able to predict this token, but it was worse. So unique ID would give you a time prefixed identifier which is supposed to be unique but not random, based on the current time in microseconds. And back in the days when this was discovered, it was the case that this unique ID always started with 4F. So then the plus operator, if you add admin with plus to the string 4F something, it would evaluate to the number 4. That again would be cast to a string of the number 4 and then put into SHA-1. So the globally working and only password reset token back at this point of time was the SHA-1 hash of the number 4, unless your username started with a number, but that's a corner case we can ignore. So yeah, that's pretty fucked up. And I mean, if you're using PHP, you should be aware of at least of this typecasting weirdness, because that's documented quite well. But yeah, resetting passwords. So another reason why I point out password resets here is when I audit an application, I usually look at the authentication and authorization parts first. So password reset is a crucial feature which can allow unauthenticated access to an application, and therefore, if you're developing an application with a password reset, special care should be taken not to screw it up too much, or not to screw it up at all, at least. So guess what? Something completely different, just another password reset. This is, again, Ruby on Rails code. This used to be, or this is actually still is a Ruby on Rails challenge I've put up. This password reset mechanism is a verbatim copy of a password reset mechanism in Discourse, which is like a online forum thingy. And I reported this and used this example as a nice challenge. So I'm going to spoil my own challenge here. If you don't want to hear it and play it yourself, you should leave the room, but please stay here. It's just a bit complex. So we try to find the user by its reset token. And if we don't find it by its token, so if the token doesn't match, we save. We don't find it, so we go to the else tree and we pull out the user ID out of the token parameter out of this session. And then we find that user, and then if we have a user here, we can reset the password. Problem being here, if we got a free lookup in here in the session, so we can say which key in the session hash will be used to find our user, and that that must not be password reset token, but it could also be a CSRF token. The CSRF token is a string which may or may not start with a number. If it starts with a number and we pull out the CSRF token here, we just say instead of a token, we say underscore CSRF underscore token, and make sure our actual CSRF token in the session starts with a number, because we can see that on the website. Then here the find method would cast that string to a number. And we find the user with the user ID of whatever our CSRF token starts with. Typically, you want to use the number 1, because then you get the admin account. And then we could reset admin's password. And the nice thing is, we don't even need to trigger an email to generate a token, because this is completely out of the session. So here again, it was a bit, I wouldn't say stupid, but brave to allow, to pull out a session value by a user-given key at this point. And their fix was actually to prefix this session parameter with a password reset something, so with a fixed string, so you couldn't inject arbitrary values at this point anymore. That was like the main part of their fix. But what do we learn? Well, password reset stinks, because it can break in so many ways. It could also be that your tokens are predictable because you're not using a good random source just by accident. But the problem is we need it, because people forget their passwords. They lose their maybe their keychain files, or they get drunk and don't know their password anymore, so they got to reset it because they go drunk shopping on Amazon. Well, that's a problem, but actually it's just an example for the whole problem space, because building secure applications, and not only web applications, is really, really hard. You just start, I mean, I myself started coding some tiny upload script, and I was like, I was done, and I was like, wait a minute, here's the directory traversal, it's not good. I shouldn't do this, but why would I even try to do this? Excuse me. So the problem is, why are you hackers so mean? Why do you do this to us? Why do you hack us? If you wouldn't tell us, there wouldn't be a problem. That's, well, yes and no, because someone always will kind of hack you. And if it's not the white hat guy, which tells you about it, it will be the guy with the ski mask, and he will not tell you, but he will rip off your database and be even more mean than the guy who discloses to you. So in a perfect world, everybody discloses, like good guy Greg. He doesn't even want a t-shirt for it. So I could rant a bit about bug bounties and t-shirts and halls of fames here, but no. So for the developer part, if you get a disclosure about something in your application, like cross-site scripting, SQL injection, and whatnot, what's next? Well, you fix the bug, and thank the researcher. You may give out a T-shirt or a bug bounty, at least credits, because hackers love fame. Well, you could do this, but no, that's not good, because you wanna go a bit deeper. Try to understand what's being brought to you, because actually you get, by getting a responsible disclosure or a security alert from a third party, you just got free consulting or free, kind of a small free audit, and should be thankful and try to find the root cause. What went wrong there? Can we include a test for this, so in our continuous integration or unit testing, so this will never happen again and we don't have to give out a free T-shirt again? Can we find other instances that the guy who reported this did not see, so we can fix even more and have additional benefits security-wise from that report? And you should really feedback and tell whoever reported this to you, could you verify this is fixed now? Because you might just have a fix which isn't 100% correct or working. So you might have overseen just another corner case. You should really make sure that your fix is kind of bulletproof. And the most important thing, learn a bit about the issue and improve, because you just got free knowledge. You should use it and improve your code and your whole infrastructure or code base upon it. So another example. Surprise from the demand page. So Gollum is, I guess some of the GitHub guys started off this project, and it's a Git-based wiki where you can online edit markdown files, and in the backend it would keep a Git repository in order to keep track of the changes you made to the wiki. Good. So this wiki has a search method. This is Ruby code again, but not exactly Rails, but Sinatra, but it doesn't matter. This is where our search ends up. This query argument we can control, the rest not. And at this point, this will be passed to the shell and invoke git grab. Good. Well, what do we see here? Well, these options just assume it's head. And that will be put here, and right before is our query, and we have here an array. So this will in the shell end up as the good way to call exec. Like you learn, you shouldn't just have a long string with a shell command, because then the hacker can come along and put in a semicolon or backticks or dollar brackets, could inject commands. So this way of shell meta-character injection isn't the case here, but something which is quite underhanded and often not seen, we can inject arguments to git grab. The actual query will become an argument starting with a dash and something, and the ref will be head, so we will have the search term being head instead of whatever is supposed to be searched for. So by consulting the git grab man page, we find the option -O, which stands for Open Files in Pager. Sweet. So the actual vulnerability and the actual exploit for this was to to search for -o, whatever shell command you want. You could even put in a simple netcat backconnect actual shell code. So you could, after the -o, you could put a complete command line. Yeah, that was funny because they thought we are safe here because we are not allowing shell characters, but then again, they weren't aware of the full spectrum of what git grep is able to do with its arguments. So the actual problem is kind of in-band signaling, which is not too obvious because POSIX says here arguments and options is all mixed in the same command line. And that's where this screw up came from. So it all looks nice, but in the end you forgot one little thing, which then is a disaster in terms of security. Right. So, so there were some showcases. So password reset and a little man page exercise. We have seen several ways of how a password reset could fail, like token being predictable or bypassable by a number instead of a string, because MySQL is weird. But how to improve? So, can you read this? No, shit. Okay. Basically, this is the git log of the AV library of Android right after JDoc reported stage fright bug to them. So I guess you all have heard of stage fright. So what you basically could see, if you could read it here, is like a whole page of commit just about integer overflows. Like enable integer checking, integer overflow checking here, fix a small non-exploitable integer overflow there. So it looks like when stage fright, and this is a non-web application example, but still, when stage fright was reported to the Android team, they suddenly were like, I guess they were like, oh my god, integer overflows, we never checked for this, let's quickly just go nuts about this. And I guess they learned something, and I hope they keep it up. Because you should if you learn it, not forget it, because then you would make the same mistake again. You should try to generalize the issue, as I said before, and try to find the pattern which you can somewhere use to find other instances in other parts of your code, in other projects, and you should try to apply it to whatever you're maintaining in order to get rid of this type of issue or bug. Even better, you should maybe read mailing lists like OSSSec, or now full disclosure is that Felix just told us this morning in the keynote. So you should have a good source of information where you can find examples of vulnerabilities, which then you should take, read, understand, and think about them. Like, would this affect me somewhere in my code? Or can I check for this type of issue even before it's introduced, because someone in the team may do this mistake, and if we got a test for this, it never can happen that he can commit because the test will fail. He will say, oh my god, my bad, but I'll never do this again, and I'll fix it in a proper way. Well, this brings us to tools. So you should try to find a fitting tool chain for your project, for your application, in order to have a good baseline of security scanning in your build or testing process. That even is true for the hacker perspective. If you have a good framework for automatically find bugs and FOPs over there, that guy, he will tell you about his tool tomorrow. So he has the bug generating machine. So, but I want to focus on the bug avoiding machine. But beware. Well, a fool with a tool is still a fool. And I don't know if anyone remembers this ancient CVE. OpenSSL in Debian. Rings a bell? Raise your hand if you remember that one. Yeah, okay, a couple of you. So, back in 2006, a Debian maintainer was like, okay, OpenSSL, quite important piece of code. I'll run an automated scanner called Valgrind on OpenSSL. And Valgrind would complain about one uninitialized variable and would tell this maintainer, hey, look, there's an uninitialized variable that's not good. Okay, the maintainer said, well, let's just initialize it and commit this as a security improvement or whatever, and that will be compiled in every Debian and Debian-based distro around the globe from 2006. And in 2008, someone figured that this mistake was made because actually the variable had to be uninitialized in order to contain enough entropy for the key generation in OpenSSL. Like every RSA key was basically just depending on the process ID of the process which created it and not any additional randomness. Oh shit. Yeah, so we had a pretty nice tight key space and could just generate every possible SSH or X509, basically every possible RSA key in a given size, which was created by a Debian between 2006 and 2008. That was pretty bad. So lesson learned, try to verify what your tool tells you, because it's just a stupid computer which tells you what to do, but you should tell the computer what to do. That's the right way around. And I mean, if you ever had a web app scanner running on a web application and get a 500 pages report and you're being told, could you verify this and that SQL injection stuff? And no, that's terrible. But yeah, so don't trust it blindly. Another thing, this is an example for another thing you should keep in mind when building an application or building a whole landscape around it. So that other day I was poking on GitHub because they have a really nice security team and fun bug bounty program. So GitHub has some internal tool called Gerf, which is basically looking at your SSH pub key fingerprint and then pulls out your user out of their database and resolves your permissions if you might, with that key, access this repo or not. So it would, if I connect to Git via SSH to git at github.com, it will look at my key and see I want to clone Fob's repo, but I may not because it's private and I'm not Fob's. So think of it as a super smart version of Git shell. Well, yes. So the front-end SSH picks up your SSH connection, looks up some stuff about you, which is signaled via environment variables, and then it would start a second SSH process on the same host to the actual backend where the repo is you want to clone or push or pull or somehow access. And I figured by messing around with my username on the web interface, I could inject environment variables to that second SSH process because it somehow got a variable which said username equals joernchen. So I polluted the environment a bit. Basically, I was able to inject new lines in my username and introduce new environment variables by this. So that was the actual payload to actually make the second SSH process spawn a shell for me on github.com. So I preloaded libfakeroot because then SSH like the SSH to the backend process, would think, hey, I'm running as root, cool. I cannot access /root.ssh known hosts, and I need to, sorry, I need to ask for a password because I actually wasn't running as root. So then I set a display variable in order to trigger SSH ASPass, while ended up in user bin X, so VI without the V, the visual stuff, and could just type exclamation mark, whatever shell command. Wonderful. Yeah, what tells us that it's not always what I call like self-contained issues. For instance, a SQL injection or a buffer overflow, you can just see in the code, it's there, if you're used to read code, it's yelling at you and saying, hey, look at me, I'm a vulnerability. But sometimes it's even more complex because you have environmental issues. You must see whatever you're running on your servers or somewhere in its context, because the environment it's running in influences, obviously, the whole application in a way. So you should, from time to time, try to switch the perspective on what you're developing, or even if you're auditing stuff, you usually get better results if you try to change the perspective, not only looking at the login procedure, but also what does the web server pass to the backend, maybe some header variables you haven't even thought about. So a bit more, or a bit open-mindedness helps a lot. Wow, 5 minutes, okay. So, ski mask time. Become a hacker. Actually, that's optional. I just would like to point out, try to be the attacker yourself if you're developing an application, and try to question a bit what's written there, because that's what those hackers usually do. They look at the code and question every single statement, every single line in order to find a flaw. And think about threats. So we got a threat here. That's Luke Skywalker. And we got our asset, which is the Death Star. And our asset, the Death Star, has a small, tiny security vulnerability. And this is the whole way Luke Skywalker flew in and blew up the whole Death Star. So we got threats. And what is next to threats? Models. Yes? More like this, more like a blueprint. So we got threat modeling. That's a great tool. Who of the guys which are developers and raise their hands does threat modeling on their code? One? Okay, if I come back next year, I want to see all your hands up. It's really helpful because if you have kind of a blueprint of your asset, which in this case is the White House, which is a pretty high value target, you should try to, I mean, I only can give you pointers, I can't explain the whole way of threat modeling right now, but you should try to decompose your application in a way it makes sense, to keep it a bit modular, and to get a good overview, and identify where are my boundaries, especially my trust boundaries. Where is the user input? Where does it stop? Where is it sanitized? Where are the threats? By drawing more or less abstract picture of your asset or application and drawing lines as boundaries, you would almost instantly see what are the threats. You might have to think about it a bit, but you would see where can they happen and how would they happen. And then you go on and mitigate the threats, and then you're not done because you repeat it over and over again, because yes, I know security is not a thing you would just plug in, it's a process, blah, blah, blah. But for a formalized approach on this, you would look up Microsoft SDL or Stride, which are the generic model of threat modeling. And I wouldn't require anyone to just follow plain SDL straight, but to adopt it in a way that it fits your needs. Because not everybody develops like Microsoft does. But that's the stuff they use themselves. So, over and over again. That's like the biggest problem I see is that people don't learn from other people's mistakes and the same types of bugs popping up over and over and over and over, and it's 2012 and we've still got format strings, exploitable format strings and stuff like sudo. Come on. Why? Let's be pessimistic for a moment. Why does this happen? People are people, and maybe they must fall down on their own in order to see what the actual problem is. People don't learn. That's bad for the product, for the software, for the whole software landscape. It's good for me. It's job security for me. Because if every now and then a new cross-site scripting gets introduced to the stuff I have to test, I'm happy, I find a bug, and I get booked again. Wow. But we should fix this like once and for all. And there are approaches to start actually computing from scratch, like start with unikernels not written in C, or yeah, the whole clean slate approach. But actually, to be realistic, I wanted to point out some things, and I hope they made it through. So, to be realistic, do not dump here. Don't be dumb. Just try to learn. Never stop learning. Try to learn from the mistakes and repeat looking at your code and doing like assess yourself and try to get a bit the mindset using the tools or you have and you can afford or can put in there. So actually that's my last slide. Thank you for your time. My counter here is at 0, so I think I'm done. And if you have any questions, I don't know, do I have time for questions? I don't see the next speaker yet, so other questions? Okay, thank you.